To begin, I navigate to the Simulation tab in Mission Planner. I set the simulation speed to 5 for a faster visual representation of the flight. Then, I choose Quadcopter from the Model drop-down menu and select the multirotor firmware. A pop-up appears, prompting me to download the latest stable firmware version. Now, I wait for SITL to establish a connection. Next, I switch to the Data tab to configure the MAVLink connection using the TCP/IP protocol with a baud rate of 115.200. Moving on to Mission Planning, I select the Plan tab and use the Polygon Tool in the upper left corner. Clicking on the map, I define the survey area by drawing a rectangle. Once the shape is completed, I right-click inside the polygon and select Auto WP Survey Grid. In the survey settings, I choose the Canon S120 camera as an example and set a flight altitude of 70 meters. The flight path angle and speed can also be adjusted here. To automate the mission, I enable takeoff and return to launch (RTL) by ticking their respective options. Under Display Options, I can visualize the survey boundary, markers, grid lines, and image footprints. In the Advanced Options, I access grid options where I can adjust line spacing, overshoot, and lead-in distance. Modify overlap and side-lap percentages. Choose grid styles like parallel, cross-grid, corridor, or spiral. Set a delay at waypoints or maintain a single heading. For fixed-wing missions, additional lane separation and spiral lap settings are available. In the Camera Configuration tab, I fine-tune the focal length, resolution, and sensor dimensions or load a sample image for automatic parameter calculation. The camera triggering method is set to cam_trig_district, ensuring images are captured at fixed distances. Additional options include do_digicam_control and do_repeat_servo for different trigger methods. Below the grid preview, key mission details are displayed, including survey area, estimated flight time, number of images to be captured, shutter speed requirements, total distance covered, grid strip count and photo intervals. Once satisfied, I click Accept and write the mission to the quadcopter. Now, I switch back to the Data tab to start the mission. I set Do Action to Mission Start, adjust Set Mode to Throw, avoiding the loiter disarm issue in fast simulations. Click Set Mode, then click Arm Disarm to power up the drone. Finally, I click Do Action to initiate the mission. Observing the flight, the drone follows the cross-grid pattern over the survey area, maintaining the defined altitude and speed. At the end of the mission, the drone returns to launch and lands And that's how you plan and execute a survey grid mission in Mission Planner SITL simulation. For more tutorials, stay tuned.